Hi, my name is Basir. In this video, I will be covering a long answer type question which has been asked repeatedly in intermediate first year examination. You can see for yourself this question which says state the law of conservation of energy and verify in the case of freely falling body has been asked in intermediate first year examination Telangana State March 2017-2019 question paper. It was asked in Telangana State May 2017-2018 question paper. It was asked in AP March 2018 question paper. It was asked in AP May 2018 and 2019 question paper. So you can see for yourself this is one of those questions which has been asked multiple times in intermediate first year examination. Let us say this is the ground here. Let us say this is the ground, and then at a height h from the ground at a point A, we have an object which is placed, and let us say the mass of the object is small m. So this is the ground. Let me write it here. Let's say this is the ground, and at a height h from the ground at a point A, there is an object which is placed and the mass of the object is small m. Now let us say, since it is a freely falling body, it is falling under the influence of gravity. So from point A, if we drop it, it reaches point B after covering a distance of x. Let us say it covers a distance x, and then it reaches point B, and then from point B, it again, it keeps falling down, and then it reaches finally point C. So we have to find out the energy, the total energy at point A, the total energy at point B, and the total energy at point C, and check for ourselves if the total energy at the point A, at the point B, and at the point C remains same. So at a height h at point A, we have an object of mass m. It falls a distance of x and it reaches B, and then from B it keeps falling and then it reaches the point C. The distance between B and C is h minus x. How? Because the total distance is h. If it falls a distance of x to reach B from A, then obviously from the total distance, if you subtract x, you will be left with h minus x. From the total distance h, if you subtract x, you are left with h minus x. So the distance between B and C is h minus x. Now let us start the answer by writing a little statement here. Energy can neither be created nor be destroyed, but it can be converted from one form to another form. The total energy of the system always remains constant. We have to show that we have to state the law of conservation of energy, and that's the statement of the law of conservation of energy. It says that the total energy always remains constant, which means the total energy never changes. Let us verify it in the case of a freely falling body. Let us suppose we have an object of mass m at a height h above the ground. When it is falling freely with an acceleration due to gravity g, the potential energy obviously decreases and the kinetic energy increases. And that is how the total energy still remains conserved. The increase in kinetic energy compensates for the loss in potential energy. When the object is falling freely under the influence of gravity, the loss in potential energy is compensated by an increase in kinetic energy, and that is how the total energy remains constant. Let us first find out the total energy of the body at the point A. Now remember, the total energy is sum of kinetic energy and the potential energy, and in general the kinetic energy is given by the formula half mv square. Kinetic energy is half mv square. Kinetic energy is the energy possessed by an object by virtue of its motion. Let us say I throw a ball at it, obviously is in motion, so it has a kinetic energy. Potential energy is the energy possessed by an object by virtue of its position, and the formula for finding potential energy is mgh. Now we'll find out the total energy at point A, we'll find out the total energy at point B, and then we'll find out the total energy at point C, and we'll check if the total energy at point A, point B, and point C remains same. When the body is at point A, the final velocity is obviously 0. why the final velocity v is 0? Because obviously the body is at rest. We have not dropped it yet. We are still holding it still. So the final velocity of the object at point A is 0. Let us find out the kinetic energy at point A. Kinetic energy is given by the formula half mv square. In place of v, I want to substitute 0 because the final velocity at point A is 0 since the object is still at rest. We have not dropped it yet. Now, half m, 0 square is nothing but 0 itself. M into 0 is nothing but 0 itself. So the kinetic energy at point A is 0. Now let us find out the potential energy. The potential energy at A is going to be mgh. Let us now write the total energies. The total energy is the sum of kinetic energy and the potential energy. Kinetic energy, we got it as 0, and then potential energy, we have it as mgh. 0 plus mgh, that gives us mgh. So the total energy at point A is mgh. Let us also find out the total energy at point B. When the body is at point B, let us find out what the kinetic energy is going to be. The kinetic energy is obviously given by the formula half mv square. But then to find out what the final velocity is going to be, let us make use of the second equation of motion, which is v square minus u square is equal to 2as. Now, v is the final velocity which I want to find out, and then u is the initial velocity, a is the acceleration, and s is the displacement. Now, the body reached point B after falling a distance of x from point A. When it was at point A, the velocity was 0. So the initial velocity of the body at point B is 0 because it started falling from point A, and at point A it was at rest, so the initial velocity was obviously 0. So here, in place of initial velocity u, I'm going to substitute 0, and then since the body is falling under the influence of gravity, in place of acceleration will be replaced by acceleration due to gravity, which is denoted by small g. And s is the displacement. What is the displacement here? See, from point A it started falling and then it reached point B, so it has covered a distance of x. So the displacement here is equal to x. Let us substitute these values here. V square, I'm writing it as it is. In place of u, I'm going to substitute 0. In place of a, I'm going to write g, and then in place of s, I'm going to write x. V square minus 0 square is nothing but 0 square is nothing but 0 itself, minus 0, which means you're not subtracting anything here. So v square remains as it is. V square is equal to 2gx. Let us substitute the value of v square here. So half m, in place of v square, let us substitute 2gx. Now what happens? 2 from the denominator and 2 from the numerator, they cancel out. M into gx is going to be mgx. We found out the kinetic energy. Let us now find out the potential energy. The potential energy is given by the formula mgh, where h is the height of the body from the ground. But at point B, the height of the body from the ground is h minus x. So in place of h, let me write h minus x. Let me replace h with h minus x. Now let us multiply this bracket with mg and open the bracket. Mg into h, that gives me mgh, and then minus mg into x, that gives me mgx. Now the total energy is going to be, again, the kinetic energy plus the potential energy. The kinetic energy here is mgx plus the potential energy is mgh minus mgx. Now, plus mgx and then minus mgx, they cancel out, and I end up getting the total energy as mgh again at point B. So the total energy at point A was mgh, and then the total energy at point B is also mgh. Let us also find out the total energy at point C. Let us find out the total energy at point C. When the body is at C, let me find out the kinetic energy and the potential energy. The potential energy is given by the formula mgh, but then at point C, you can see for yourself the body is on the ground. So the height of the body from the ground is 0. So in place of h, we are going to write a 0 here. So h is being replaced by 0. mg into 0, that gives us 0. Let us find out the kinetic energy. The kinetic energy is obviously given by the formula half mv square. Let us find out the value of v square again from the second equation of motion, which is v square minus u square is equal to 2as. In place of u, I am going to write 0. In place of a, I'm going to write g, and then in place of s, this time I'm going to write h. Why? Because s is the displacement, and when you can see for yourself, the body, it fell a distance of h to reach point C. So with the body when it reached point C, by the time it reached point C, it has covered a distance of h. So in place of s, let us write h here. So v square minus, in place of u, I'm writing a 0. In place of a, I'm writing g. In place of s, I'm writing h. V square, 0 square is nothing but 0 itself, minus 0, which means you're not subtracting anything from v square, so v square remains as it is, 2gh. So in place of v square, let us substitute 2gh. In place of v square, let us write 2gh. This 2 and this 2 cancels out, and we are left with mgh. So the total energy again is going to be the sum of kinetic energy and the potential energy. Kinetic energy, we got it as mgh, and then the potential energy, we have it as 0. mgh plus 0, that gives us mgh. So the total energy at point C is also mgh. The total energy at point A, we got it as mgh. The total energy at point B, we got it as mgh. And then the total energy at point C, we got it as mgh. And so we can say that the energy is conserved in the case of a freely falling body. Every time this question is asked in the examination, you also get a numerical with it. But then I will cover the numerical in one of the upcoming videos. For now, we have reached the end of the video. I hope you understood the concept here. I look forward to see you all in the next video. Have a great day ahead. Until then, goodbye.